Number 11, what's the dynamic range for a 9-bit sine magnitude? Take note, this is sine magnitude. Pag tayo ay nagka-quantize, kina-quantize natin yung analog signal, hindi kasama yung sine. Yung sine kasi will give us the direction of the signal, whether it is going positive or going negative. Pero pag ang hinahanap natin is yung mismong value, we don't use the sign. Okay? So pag kinuha natin yung dynamic range, hindi 9-bit ang gagamitin natin. We will be using only 8. Tama? So in calculation, how do we compute for this? This will be dynamic range equal to 2 raised to n minus 1. And of course, kung naka-dB yan, yun yung nasa choices natin, no? Lahat yan ay naka-dB. That will be 20 log of 2 raised to n minus 1. Why 20? Because we use voltage instead of power. Okay? And 8 yung gagamitin natin. Sabi nga natin kanina, we use here 8 instead of 9. Dahil hindi kasama yung sign doon sa quantization level. So 2 raised to 8 minus 1, you get the logarithm of that, then multiply it by 20. The answer will become 48.13 dB. And of course, that is letter C for number 11. Okay? Next number. Number 12. With frequency modulation, maximum frequency deviation occurs blank or at the blank of the modulation signal. Actually, this should be of the modulating signal. The modulating signal is the information. So, kailan daw nangyayari yung maximum frequency deviation or that is the frequency change? Kailan daw? Nangyayari yan sa peak value. Tama? Sa positive o sa negative? That will be in both positive and negative peak values. So, for number 12, letter B. Okay? Next number. Question number 13. The most important database in GSM. Okay, maraming databases meron sa GSM. We have the HLR, the VLR, the AUC, the AIR, and many more. Pero ano raw yung pinaka-importante sa lahat? Pinaka-importante sa lahat is letter A. That's the HLR or that is the Home Location Register. Okay? Bakit siya yung pinaka-importante? Because it stores the permanent data about subscribers. While yung VLR, from the name itself, is a Visitor Location Register. It only stores information temporarily of a subscriber within a service area. Okay, kaya ang pinaka-importante is the HLR or the Home Location Register. That's number 13, letter A. Next number 14. Ito madali lang ito, no? What is the actual length in feet? In feet, we're talking about feet. Okay? Not in meters, but in feet. Of 1/2 wavelength of a coax with a velocity factor of 0.57 at 25 megahertz. The operating frequency is 25 megahertz. How do we compute for the wavelength in feet? That will be wavelength is equal to napakadali ng calculation ito, no? C over F times VF. VF being the velocity factor. Then the C or C, that is the speed of electromagnetic wave in free space. If that is in feet per second, that is 984 times 10 to the 6 feet per second, divided by the operating frequency, which is 25 megahertz or 25 times 10 to the 6 hertz, multiplied by the velocity factor of 0.57. So we can solve for the wavelength, which is 22.43 feet. And then we're going to divide it by 2 because we are asked of 1/2 wavelength. Okay, so di-divide lang natin sa 2 and it will give us 11.21 feet. Okay, so the answer is letter C. Okay, kung hindi mo naman alam yung C in terms of feet per second, pwede mo naman gamitin ito in meters per second. This will give you meters. Divide mo sa 2 and then convert mo into feet using your calculators. Okay, so that's number 14, letter C. Okay? Next number, number 15. For number 15, a half-wave dipole is added with three conductors. What will happen to the feed point impedance? The feed point impedance, of course, uh, pwedeng mag-increase yan. Tama. Sinagot ko na eh. So the answer is letter A, increase. Paano siya nag-i-increase? Ganito yan. Ang impedance kasi natin, that is 73 ohms for half-wave dipole. But if you're going to add more conductors into the half-wave dipole, it will become a folded dipole. And we all know that folded dipole has impedance greater than the half-wave dipole. And paano yung calculation of the impedance of a folded dipole? Having two or more conductors. That is 73 times n squared, where n is the number of conductors. Okay, so habang dumadami yung conductors natin, ang impedance naman natin lumalaki. So the answer is letter A for number 15. Okay, next number. Number 16. Question number 16, it establishes the minimum sampling rate that can be used for a given PCM. Alam na natin ito, no? That is sampling rate must be greater than or equal to twice of the analog frequency, and of course that is letter A. That's what we call the Nyquist sampling theorem. For number 16, that's letter A. Okay, let's move on. Question number 17. It is the data rate at which the serial PCM bits are clocked out of the PCM encoder into the transmission line. Ano daw ang tawag natin dito? Simple lang yung definition niya, no? Pag inoorasan mo yung number of bits that is coming out of a PCM encoder, ang tawag natin sa parameter na yon ay line speed, letter B. So pakitandaan po, number 17, that is the very definition of line speed. Pagdating sa board exam, the definition may vary a little, but ganun pa rin yung kanya magiging sagot. So pakitandaan po yan, letter B, line speed. Question number 18. For open circuit transmission lines, at what points where voltages are maximum? Every wavelength, every half wavelength, every quarter wavelength, or every other wavelength. Okay. So kanina pinag-usapan natin ito. Ang sabi natin na yung transmission line mo ay pagdating sa dulo, ano raw yung voltage niya of an open circuit transmission line. The voltage here is maximum. Take note, that is the standing wave voltage. Okay. Now, ang hindi natin sinabi ay tuwing kailan. Tuwing kailan siya maximum voltage. Take note, that is kapag ka meron kang quarter wavelength. Okay, so every quarter wavelength, nakakaroon ka ng maximum voltage. Okay? So ibig sabihin, ang sagot, letter C, every quarter wavelength. Bakit? Kasi sa quarter wavelength, nagkakaroon tayo ng impedance inversion. Ang open circuit will have sabi natin sa open circuit, ang open circuit na quarter wavelength, ang equivalent niya ay series resonant circuit. Tama? At ang series resonant circuit will give us an impedance that is minimum. Saan yon? Minimum yon sa input. Input ng ano? Input ng transmission line. This will give us a minimum input. Minimum input impedance. And quarter wavelength away from that will give us maximum impedance at the output. So therefore, yung voltage natin, since ang impedance natin is maximum at the end, at open circuit transmission line, this will give us also maximum voltage. Okay? At nangyayari yon every quarter wavelength, not every half. Bakit? Kasi pag dinagdagan ko ito, this is only quarter wavelength, tama? Pag dinagdagan ko ito ng another quarter wavelength, yung dulo niyan will have again an impedance inversion. So therefore, yung maximum magiging minimum. So every half, you will have minimum voltage. No? And then kung every 3/4 naman, pwede rin na maging maximum ulit, pero wala naman 3/4 yan. No? And also, you have every wavelength. Every wavelength will give you also minimum voltage. No? Kasi pang-apat na yon na quarter wavelength. So, magbibigay yun ng minimum just like the half. Okay? And every other wavelength, of course, katulad lang din ng isang wavelength yan. So, the best answer for this is letter C for number 18. Okay? Next number 19. Question number 19. What is or are the disadvantages of surface waves? Ano raw yung mga disadvantages? Ano raw yung disadvantage o mga disadvantages of surface wave? No, kasi meron tayong any of this. Question. Ground waves require relatively high transmission power. Is that a disadvantage? Of course, this is a disadvantage. So A na ang sagot. Tama? But wait, there's more. Letter B. Ground waves are limited to very low, and medium frequencies requiring large antennas. Is that correct? Yes, that's correct. So therefore, even though you have a little doubt on letter C, this will have a conclusion that letter D is the correct answer. And sure enough, the answer is letter D. Any of this. Ground losses vary considerably with surface material and composition. That is true. That is also a disadvantage for surface waves. And what are the advantages? Here are the advantages. Baka itanong to sa board exams. No? So alam natin yung disadvantages. All of these three are the disadvantages. Now, what are the advantages? Advantages of surface waves are, number one, given enough transmit power, ground waves can be used to communicate between any two locations in the world. So, pwede nitong libutin yung buong mundo kung mabibigyan lang ng enough transmit power. Okay. Number two, ground waves are relatively unaffected by changing atmospheric condition. So, kahit umuulan, bumabagyo, very reliable ang ground wave communication. So these are advantages of surface waves. And that is for number 19. Next number 20. The basic antenna. Ano bang basic antenna? Ang basic antenna is definitely a passive antenna. Okay, passive. So letter A at saka D na lang ang tamang sagot. Wala na yung B at C. Pero ang passive antenna can be used as transmit antenna and receive antenna. So therefore, reciprocal device yan. So the answer is passive and reciprocal. So number 20, letter D.